figure shows a setup used in school laboratory to verify the principle of parallelogram of forces. A. Smooth pulleys. B. Vertical drawing board with a white paper pinned on. C. Light string. D. Light scale pans. P, Q and R weights. Part A. Give a list of other items needed to carry out this experiment accurately. We know that when marking positions of strings, we have to use a set square or a plane mirror. Therefore, we have to write other items, a set square or a plane mirror. We have to place the plane mirror like this, and when moving eye, we can observe a position that the image formed by the plane mirror, image of a string formed by the plane mirror is coinciding with original string. We have to mark 2 points on the white paper at that situation. Or we can do same thing by using a set square. We have to place 90 degrees angle of set square such that it touches the string end. Then we can mark 2 points like this. Therefore, we have to use a set square or a plane mirror. Then, when constructing parallelogram, we have to use a pair of compass. Or we can use protractor. And we have to use the ruler to measure the diagonal, length of the diagonal of parallelogram, and when drawing sides of parallelogram, we have to use the corresponding scale. When using a scale, we have to draw parallelogram by using ruler. Then part B, how do you test whether the friction of pulleys is negligible? We can pull middle scale pan downward, and we can check that, check whether it is returned into the original position. Then we have to write answer for part B. Pull the middle scale pan downward and check whether that it returns to the original position. In part C, if the above arrangement is set up for you, briefly state the steps that you would adopt to verify the principle of parallelogram of forces. We have to mark positions of each string. Then mark positions of strings using plane mirror or set square. Then we have to construct the parallelogram by using a suitable scale. construct the parallelogram by using a suitable scale. Suitable scale means we have to get a scale like 1 centimeter representing 1 Newton, because of we are drawing P, Q and R weights as the scale. Especially we are drawing these two diagonals, these two sides by using a corresponding length to the P and Q. This side length should be proportional to the weight of P. This side length should be proportional to the weight of R. Then, as the third step, we have to complete this parallelogram. After completing parallelogram, we have to check the diagonal of parallelogram. Is vertical and length of diagonal is proportional to the middle weight. Middle weight is Q, proportional to Q. Then next part D. In order to carry out this experiment, light strings should be used. What is the reason for this? If we are using a heavy string, tension of the string is changing with position along the string. But we are considering that tension of string is equal to the hanged weight of the corresponding string. Then we can write tension of string, tension of a heavy string is changing along the string. Then part E. After completing the parallelogram correctly, a student noticed that direction of relevant diagonal was not exactly vertical. Give a reason for this. We can write pulleys are not frictionless, but it is not the best reason, because of we are checking before starting the practical that the pulleys are frictionless. Therefore, we can write drawing board is not vertical. If there is an inclination of drawing board like this direction or this direction, we can't obtain a vertical diagonal. Therefore, if we are getting a diagonal and if it is not vertical, it could be due to due to friction of pulleys and the inclination of drawing board. Then part F. If the scale pans are not light, what should you do in order to carry out the experiment correctly? We can add mass of scale pan to the corresponding masses, and we can get the total mass, and we have to draw the parallelogram by using a scale with total mass. Total mass means total weight means weight of scale pan and weight of empty scale pan and weight of corresponding mass in a corresponding scale pan. Therefore, we can write, we have to add weight of scale pan to the corresponding weight. Corresponding weight means PQOR. When getting weight of P, we have to get weight of P and corresponding scale pan weight as the resultant weight. Then we can draw the parallelogram by using corresponding scale. Then part G. This setup is used by a student to find the weight of a stone. The relevant sides of the force parallelogram are shown in the figure. Evaluate the weight of the stone. They have given that 1 centimeter is equal to 2 Newton, and they have marked in the diagram 1 centimeter is 2 large squares. Then we have to complete the given parallelogram, and we have to obtain the corresponding diagonal length. Diagonal length means this one, and we can observe that there are 6 squares. 6 squares corresponding to the length of diagonal. They have given 2 squares representing 2 Newton, then 6 squares representing 6 Newton. Then answer is 6 Newton for the part G.